Okay, so before I begin on to part C, I just wanted to reiterate what I said in one of the past videos. I have these two angles here, right? This is why I had found the tangent of these two of the hypotenuse of the opposite and the adjacent, because these angles help me with the method that I used to discover the acceleration as the boy was lifting the ball up in his hand before leaving. So 72 degrees and 38.66 degrees. When using the x and y components, I had done exactly that. So I used the initial velocities and then the final velocities in order to find out what the x velocity and the y velocity should be. Sorry, I should let that focus. And the reason why the x velocity is negative is because this value is actually less forwards than the x-axis and moves towards the y more accurately. And then it looks, I should probably erase that a little bit better, but that little subtraction sign is just a human error. This is actually positive 1.7 meters per second. And then to discover the velocity, I've done exactly what I did for the velocity right before the experiment started and right after his right after the ball exited his hand, right? I used the x velocity and the y velocity, and then I just simply found the hypotenuse of those two, because the acceleration is also in an angular motion. It's not in a straight line. So after that, I had basically done exactly what I did before, and then just used the change in velocity, the hypotenuse, over the time, which was also relatively easy to find because it's simply 0 up to right before he lets go of the ball. And then I simply just divided those two, and then I got 20.7 meters per second squared, which is quite the realistic answer, and I moved on to the next part.